This is the principal component of hydroelectric scheme. The principal component of a hydroelectric scheme are as under: intake structure, forebay, surf tank, penstocks, conveyance systems, powerhouse, draft tube, tail race. Intake structure. An intake is a structure constructed at the entrance of the pipe or canal or tunnel through which water is conveyed to the powerhouse. The intake serves the following functions. It controls the flow of water into the conveyance system. It prevents the entry of debris, ice, boulders, etc. into the conveyance system by means trash rasks. It prevents the heavy sediment load of the river from entering the conveyance system with the help of slit traps and slit extruders. It provides a smooth, easy and turbulence-free entry of water into the conveyance system. Types of intake. The type of intake most suitable for a particular project will depend upon the type of storage or diversion structure, the location of the powerhouse, the conveyance system, topography, etc. Commonly used intake are dam intake, runoff river intake, canal intake, power intake, shaft intake. This is the forebay. A forebay is an enlarged body of water provided at the downstream end of the canal, just at the upstream of penstocks, to acts as a small balancing reservoir or pond. The main functions of the forebay is to store some water to act as a regulating reservoir for the penstocks. The forebay should be provided with an outlet or spillway to dispose of the water safely whenever required. A forebay is usually created by widening the downstream end of the power canal into the form of a small basin. Sometimes a bypass is provided to convey water from the forebay to the tail race when the load is reduced. Surf tank. If the conveyance system consists of a penstock under a very high pressure, a surf tank is usually required at the upstream of the powerhouse to reduce the water hammer effect. Functions of surf tank. It provides a free reservoir surface just upstream of the turbine intake to absorb and compensate water hammer effects. It reduces the length of the high pressure conduits required to resist the water hammer effects. It quickly depends the water level fluctuations following load changes. Observe carefully. This is a surf tank. Fourth one is penstocks. Penstocks are the pressure pipes which convey water from the intake to the turbines. If the powerhouse is located at the toe of the dam, penstocks are entirely embedded in the dam. When powerhouse is located away from the dam, penstocks are provided to take the water from the dam to the powerhouse. Sometimes a canal is provided in initial reach ending in a forebay and the penstocks are provided in the remaining reach. When the distance between the forebay and the powerhouse is relatively short, a separate penstock is provided for each turbine. This is the diagrammatic representation of penstocks. And fifth one is conveyance systems. A conveyance system is required to carry the water from the intake to the powerhouse. It may consist of one of the following: canals, closed conduits, tunnels, penstocks. When the general topography of the terrain is moderated and the discharge is large, canals are generally most suitable. The tunnel may have pressure flow or free flow. When the ground is very steep and rugged, penstocks are more economical. In the case of an open channel, a forebay is usually provided at the end of the channel, from which the water is conveyed to the turbines through penstocks. Sixth one is powerhouse. A powerhouse is a building constructed for housing and protection of the various hydraulic and electrical equipments required for the generation of power, such as spiral causing, turbines, governors, draft tube, generators, etc. The powerhouse consists of three main components. First one is substructure, second one is intermediate structure, third one is superstructure. And observe carefully, this is the powerhouse's diagrammatic representation. And seventh one is draft tube. A draft tube is a pipe or passage of gradually increasing cross section area which connects the runner exit to the tail race. It serves the following purpose. It permits a negative or suction head to be established at the runner exit, thus making it possible the placing the wheel and connecting machinery at level above that of water in the tail race under high water flow conditions or river without loss of head. It reduces the high velocity of the water discharged by the turbine by gradually enlarging the cross section and thus convert the kinetic energy of the water leaving the runner into mechanical energy of the wheel. Thus, it acts as a recuperative or pressure energy. This is draft tube. Observe carefully. In these four diagrams are present, and it is tail race. Ninth one is tail race. Thank you for all listening my words with patience. Thank you for all.